Rate of change and slope. Rate of change, a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. Okay, if you remember, there is an acronym called DRY, mix. The dependent is on the y-axis, and the independent is on the x-axis. Slope, the measure of the steepness of a line on a graph. Okay, how do we find slope? Well, slope is the rise over the run, or we call it the change in y over the change in x. How do you find the change in y? Well, you say y2 minus y1 over x2 minus x1. So you're just picking two ordered pairs and finding the change in them. Some other things that I want to remind you about slope. When we're talking about a positive slope, will look like this, where it's going up, it's rising. Now we have also a negative slope. Our negative slope is going to look like this. Okay, there are also slopes where you have a zero slope. So if we have horizontal lines like this, the slope is 0. And the last one is when we have a vertical line. A vertical line is called undefined. All right, so let's go to example 1. On example 1, Eve keeps a record of the number of lawns she mows and the money she has earned. Tell whether the rates of change are constant or variable. So if we're doing K, which is y divided by x, or we're doing, sorry, not K, but if we do M, slope, y2 minus y1 over x2 minus x1. Okay, so if we do the difference between day 1 and day 2, we can call this our y2 and this is our y1. 45 minus 15 is 30. This is our x2, 3, and this is our x1, 1. 3 minus 1 is 2. 30 divided by 2 is 15. Then we do it between day 2 and 3. 90 minus 45 is 45. 6 minus 3 is 3. 45 divided by 3 is 15. And if we do it from day 3 to day 4, 120 minus 90 is 30. 8 minus 6 is 2. 30 divided by 2 is 15. So we have y equals 15x. Okay, and that's a constant rate of change. It's a constant of proportionality also. All right, and if we want to tell if it is constant or variable, it is constant. Okay, number 1, the table shows the appropriate height of a football after it's kicked. Tell whether the rates of change are constant or variable. All right, so if I said 18 minus 0 and 0.5 minus 0, I would get 18 over 0.5. Which would be 36. All right, and if I did 31 minus 18 and 1.5 minus 0.5, so I have 31 minus 18, I get 13, 1.5 minus 0.5 would get me 1. 13 over 1 is 13. Right here, 36 and 13 are not the same. If I want, I can keep going. I can do 26 minus 31 and 2 minus 1.5. 26 minus 36 is negative 5. 2 minus 1.5 is 0.5. So this would be negative 10. The constant rate of this is not a constant rate of change. This is a variable. And the rates of change are 36, 13, and negative 10. All right, let's take a look at the back side. So let's take a look at this graph. We have the ordered pairs 115, 230, 345, and 460. So if we want to find the rate of change between 1 and 2 hours, we can do 30 minus 15, we get 15, and 2 minus 1, we get 1. 15 over 1 is 15. All right, between 1 and 4. So we have 60 minus 15 and 4 minus 1. 60 minus 15 is 45. 4 minus 1 is 3. 45 divided by 3 is 15. Okay, between 2 and 4, so we have 60 minus 30 and 4 minus 2. 60 minus 30 is 30. 4 minus 2 is 2. 30 divided by 2 is 15. So if we're going to write an equation, it would be y equals 15x. This is a straight line and it passes through the origin. So this is a proportional relationship. Okay, part D, recall the graph of a proportional relationship is a line through the origin. Explain whether the relationship between Nathan's time and distance is a proportional relationship. Yes. It is a straight line that passes through the origin. Okay, let's take a look at the next one. All right, so calculating the slope. Choose 2 points on the line, find the change in the y values and the change in x values as you move from one point to the other. Okay, so let's say that I choose this point and this point here. Okay, so this point is 1, 2, 3. So -3. And it is going up 2. And this is the origin, so 0, 0. So if we do y2 minus y1 over x2 minus x1. All right, so we can say 2 minus 0, and we can say -3 minus 0. It doesn't matter which one we choose to come first, but if you call this y2 and this is y1, then you have to call this x2 and x1. Just be consistent with your labels. Okay, 2 minus 0 is 2. -3 minus 0 is -3. Now notice when you have this with the negative in the denominator, it's also the same as this with the negative in the numerator and with the negative on the outside of the fraction. Either way you want to write it, it doesn't matter. Typically, I probably write it in this format, but this is also acceptable. We really don't ever put the denominator, the negative in the denominator, but it can be written like that. Also, I want you to know that besides picking 2 ordered pairs, you can just take a look at the graph and notice that it is going down 2 and it is going to the right 3. Okay, so that's another way to look at it. It is going down 2 to the right 3. Let's take a look at the last one. The graph shows the rate at which water is leaking from a tank. The slope of the line gives the leaking rate in gallons per minute. All right, so if we want to talk about the rise, we are going up 1, 1, 2, 3. So the rise is 3. The run, 1, 2, 3, 4. So we have 3 over 4. If you're not comfortable with doing it by the graph going up 3 to the right 4, you can also choose to pick the 2 ordered pairs. So if you want to pick this first ordered pair, which is 4 thirds, and then the origin, and doing y2 minus y1, x2 minus x1, you can say 3 minus 0 over 4 minus 0, which is 3/4. By the way, these are both proportional relationships because they are straight lines and they both pass through the origin.